My paper title is Deep Data Analyzing Method based on Scale-Space Theory. Scale-space theory has been introduced into the field of big data, but its research is still not deep enough and perfect because of the lack of universal theory and method. With deepening of big data processing applications, the research becomes more and more urgent. In view of the above question, this paper studies pervasive multi-scale data analysis theory and method. On the other hand, we give the definition and partition of data scale as well as the relationship of multi-scale data set between the upper scale and the lower scale based on conceptual hierarchy theory. On the other hand, we classify the definition of multi-scale data analysis, study essence, and classification method. Part 2. Multi-scale for data. This part has 3 aspects. A. Conceptual hierarchy. Conceptual hierarchy C is a partial order set, where C is a finite set of concepts. No more than denote C contains a partial order relationship between concepts. A category attribute data sets that have a distinct conceptual hierarchy partial ordering, corresponding to the partial order relationship in limited concept set. Attributes can form a partial order relation depend on domain knowledge. B. The basic concept of data scale. In the concept hierarchy, the partial order indicates concept involved range, the relative size of particular size, or the relative length of time amplitude. Then call this concept hierarchy with a multi-scale feature. Using the concept of hierarchy multi-features as the standard for dividing. The data set may be formed multi-scale data set. C. The relationship between multi-scale data sets. This based on conceptual hierarchy theory. The upper and lower scale data sets are relative concepts. The conceptual level of data scale in upper scale data set is higher. Partition granularity is larger. Data set containing data meaning is more generalization. The conceptual level of data scale in lower scale data set is lower. Partition granularity is smaller, so it contains the meaning of data more clear and specific. Part 3. Multi-scale data analysis. This part has 2 aspects. A. Definition of multi-scale data analysis. The main task of multi-scale data analysis has 2 aspects, that is, the multi-scale implementation of data and knowledge of multi-scale mining. The former belongs to the data pre-processing. The data partition of scale can be realized. The latter needs improvement technique in detail. In the form of multi-scale data knowledge discovery, analysis, and knowledge derivation are connected with each other. The definition of multi-scale data analysis is given in this paper. Multi-scale data analysis refers to the data where multi-scale processing form a set of multi-scale data. Use or improved data analysis technique explore multi-scale data of implicit knowledge and analysis of derived data of various scales form behind the knowledge between relations. B. The essence of multi-scale data analysis. The multi-scale transformation of knowledge is the essence of multi-scale data analysis. Part 4. Multi-scale data analysis algorithm. Based on the benchmark scale and scale conversion mechanism. This paper proposes the basic framework of multi-scale data analyzing algorithm. The basic idea of the framework is first select benchmark scale on benchmark data sets used in data analysis algorithm to get the results of the analysis. Then, for any other target scale through the use of scale conversion mechanism and the conversion methods, standard BS analysis results or knowledge invention to target scale through direct access to the target scale data set behind the implicit knowledge of the approximate results. Rather than target scale data set for direct analysis, the ultimate realization of multi-scale data analysis. The specific steps of the algorithm framework are as follows. Input: data set with the characteristic of multi-scale. Output: results of the data analysis on the target scale. Step 1. Select the benchmark scale of data set. Step 2. Use data analysis algorithm on data set of benchmark scale. Step 3. While the target scale is not benchmark scale. Step 4. If target scale no more than benchmark scale, run scale down analysis algorithm, benchmark scale to target scale. Step 5. Else if benchmark scale no more than target scale, run scale up analysis algorithm, benchmark scale to target scale. Step 6. Exit while all data have been executed. If the target scale is smaller than the benchmark scale, call scale down algorithm analysis. Conduct knowledge scale down conversion through benchmark scale down analysis and reverse conduct the results on the target scale. If the target scale is bigger than the benchmark scale of the analysis show, the scale is larger than the benchmark scale, called scale up algorithm analysis. Conduct knowledge scale up conversion through the benchmark scale analysis and reverse conduct results on the target scale. If the interested scale has been analyzed, the algorithm ends and returns to the analysis of results of each scale. Part 5. Conclusion. This algorithm is applied to multi-scale analysis of association rules. Proposed the multi-scale analysis of association rules algorithm. Numerical analysis results with benchmark data sets. Enter the benchmark data set for target scale data set weight that is the target scale data sets of association rules behind the realization of the cross-scale derived knowledge. Provides the possibility for multi-scale decision. Previous studies show that the proposed method has a high coverage rate, high accuracy rate, lower error rate of support estimation degree, and greater improvement in the efficiency than the traditional algorithm. That's all. Thanks.